To all of you watching this video, thank you. I am Mr. Ish. I hope everyone's having a good morning. We're here looking at this integral root 1 plus 4x squared dx. It very well mirrors the integral form you saw very recently, except in that, in terms of that root, we had a 1 plus x squared, and we saw how that went through that secant cube route where we brought the reduction formula. I want to take this via that same procedure. I have to somehow convert this 1 plus 4x squared into a 1 plus x squared, and I can do that by means of a substitution. We know here easily a is equal to 1 because we see that right here. I have a 4x squared. If I can convert 4x squared into just an x squared, I could be very much better off. How about this? X is equal to 1 over 2 tan theta. Then we would do a dx is equal to 1 over 2 secant squared theta d theta. Eventually we will need this, and I'm going to just get this out of the way right now. If I were to look at this expression here and solve for theta, I would have theta is equal to arc tan 2x, which I know is a 2x over 1. We'll need that later on, so we've gotten it out of the way. Now we have these substitutions, we put them right over there. I'm looking at now a 1 plus 4, and in place of x I'm putting a tan theta over 2 because it's 1 over 2 tan theta. So tan theta over 2 square, and then I have outside 1 over 2 secant squared theta d theta. This 1 over 2 can come out at the very beginning of your integral, and there's nothing wrong with you doing that. We will look at exactly this part right here. We have a 1 plus, I have a 4 times tan squared theta over 4. The 4's will cancel out. I'll just have 1 plus tan squared theta. But I know 1 plus tan squared theta in terms of the identity is equal to secant squared theta within that root. That root has a secant squared theta, which by means of this square root becomes a secant theta. That secant theta combines with that secant squared theta, and I end up with a secant cube theta, and I have a d theta. The 1 over 2 square, which is a 1 over 4, got erased and cancelled out, but this 1 over 2 has been pushed out, and now I'm exactly where I want to be, and I can utilize a power reduction formula or just a reduction formula. The reduction formula for anything which looks like this, secant to the power of n, here n is being 3, we have that is equal to n minus 2 divided by n minus 1. There's an integral part which you can say here is a secant. You have a n minus 2 over here, and then you have a theta d theta. Then there's a part which is already in terms of an antiderivative, that is secant n minus 2 theta tan theta all divided by n minus 1. This is the reduction formula that I need to utilize, or I want to utilize to handle that. And it's not hard. I would have this 1 over 2, and it would literally stay outside. Everything within this would be affected at the end by that 1 over 2. I have an n minus 2, n minus 1 here, n is equal to 3. I end up having a 1 over 2, then I have an integral here, secant theta d theta, and then I have the antiderivative which is secant theta tan theta over 2. All of this is not too hard. This is easy. I have a 1 over 2, then I have a 1 over 2 natural log. The antiderivative of this is secant theta plus tan theta, and this part is already a part of your entire antiderivative. Secant theta tan theta in a product relationship divided by 2. I'm not writing a plus c because we're not done. Now we have to look at this part right here, which we've already focused for you earlier, and we have to draw a triangle with regards to this theta. We will determine everything. Theta is equal to arc tan 2x over 1, and then this right here must be equal to 1 plus 4x squared within the root. We will look at this expression right over here, and what we will do is handle these denominators. I have a 1 over 2 here, I have a 1 over 2 here. Why don't I just cancel these 1 over 2's? Because I have a 1 over 2 outside, everything would really literally be a 1 over 4 sitting outside. Because as you open it up, all of this will adopt this denominator of a 4. Remember, there's nothing wrong here. I have a 2 over here in denominator, I have a 2 here in denominator. Everything is literally already over 1 over 4, which I've pushed aside. Now all I have to do is open this up, and I will do so. We will do it right over here. Natural log secant theta plus tan theta. Everything with regards to theta will come right into play. Secant theta of this angle is going to be root 1 plus 4x squared. Tan with regards to that theta will be plus 2x. You'll close this absolute value parentheses, then you have this plus right here, then you have this product. Secant theta tan theta, I want to do the tan theta first. It will be a 2x, and then I want to do the secant theta, which will be root 1 plus 4x squared. Now I'm going to bring out And into play this 1 over 4, it'll come right over here, over 4, and then there's a plus c, and that right there is our antiderivative. The question has been completed. I'll verbalize it for you. Integral root 1 plus 4x squared dx has the antiderivative natural log, absolute value, root 1 plus 4x squared plus 2x. This looks a little less like a square, so we should clean it up. I'll verbalize it again. Natural log, absolute value, root 1 plus 4x squared plus 2x, close the absolute value, plus 2x root 1 plus 4x squared all over 4 plus c. There could be another route for you to doing this, but remember we're looking at this power reduction or this secant reduction formula, and we're learning how to apply that, which is why we're showing you this route, and there's nothing wrong with this route. I like this route. And that's it. Thank you. Have a nice day. Bye.